In our final Unit 2 review packet video, we'll be covering Topic 6, Proofs. Name the property used to make the conclusion. Here we have x equals x. Everything is equal to itself. The property that allows us to say that is the reflexive property of equality, which we'll just write as reflexive. If AB equals CD, then CD equals AB. You're allowed to flip around the two sides of the equal sign and not change anything. That is the symmetric property of equality, which we'll just call symmetric for now. And finally, if BC equals DE and DE equals FG, then BC equals FG. Well, we've seen this a few times before, but basically it says if we can go from BC to DE and then from DE to FG, then we should be able to go from BC straight to FG. That is the transitive property of equality. And I'll just write property of equality, POE. Here we have a proof. Solve the equation, give a reason for each step. To solve this equation, the first thing we would do is distribute. When I'm doing a proof, especially an algebraic proof like this, I like to do my equation step first and then come up with a reason that I'm allowed to do that afterwards. Here we've got our first thing. Our first statement is always, our first reason is always going to be the given, so I'll write given here. And then to solve this algebraically, I would distribute. Now in a proof, we don't necessarily show our work. Instead, we just kind of write down the result of what happens when we do that work on the next line. So I'm just going to put in pink my work here. I'm going to distribute that -3, and then I'm going to distribute that 5. But in the actual proof itself, I'm only going to write down what happens when I multiply. So -3 times 2 would be -6. -3 times -x would be +3x. 5 times x, 5x, and then 5 times 4, 20. On the right side, under reasons, here's where I have to give the property that allows me to do that. Well, we even use the word distribute. This would be the distributive property. The next thing I would do if I was solving this equation is try and get all my x's onto the same side. To do that, I would subtract 3x. Just so I don't lose track of my work, I'll write 3x there, but on the next line of my proof, that's where I'm going to put the result of doing that. So my -6 wouldn't change, that cancels out. 5 minus 3x would be 2x, and then plus 20. When you subtract a number from both sides, you're using the subtraction property of equality. So on the right side of my proof, my justification for this, subtraction property of equality. Now, if we have to keep writing out subtraction, addition, division, multiplication all the time, these proofs are going to get pretty long. So I'm going to abbreviate the subtraction property of equality as SPOE, S-P-O-E. Subtraction property of equality. Step 4. If I was solving this equation, the next thing I would want to do is move this 20 to the other side. So I'm going to subtract 20 from both sides. That'll give me -26 equals 2x. Just like last time, I subtracted from both sides, so that's going to be the subtraction property of equality, SPOE. Step 5. If I were solving this equation, the next thing I would do to get rid of that, 2 and get x by itself, is divide. I'm going to divide both sides by 2. -26 divided by 2 would be -13. The reason I'm allowed to do that, well, if I divided both sides, that's got to be the division property of equality, DPO. Many times people will end the proof here and say, well, I've solved for x, -13. If you like, you can add a 6th step to kind of flip this around and get the x on the other side to say x equals -13. It's not strictly required in this proof because there was no target to prove at the beginning, unlike question 29. In question 29, it says prove angle 1 is congruent to angle 5, which means that the last line of our proof has to look exactly like this. Because nothing here said prove x equals negative 13. We're not required to use a symmetric property, but if we wanted to, we could flip this around doing that. So what allows me to change it? This is the symmetric property of equality. For our final proof, we'll be going over geometric proof. Let's complete the following proof. Given angle 2 is congruent to angle 4, angle 1 is congruent to angle 5. Sorry, prove angle 1 is congruent to angle 5. Statements, angle 2 is congruent to angle 4. That's our given. In general, when doing a geometric proof, the first thing I want to do is I want to look at the picture to see if there's anything in the picture which will justify this statement. If there's nothing in the picture that's going to justify this statement, then I'm going to look at whatever things came before it and see if my previous statements can help me justify this. So first we have angle 2 is congruent to angle 5. Looking at my picture, here's angle 2 and here's angle 5. These are vertical angles which we learned about in Unit 1. So my justification is going to be that they're vertical angles, also known as the vertical angle theorem. Now, nobody wants to write vertical angle theorem a bunch, so from now on, we'll abbreviate that VAT. Next, we have angle 5 is congruent to angle 4. Looking at my picture, angle 5 and angle 4 are adjacent. However, there is nothing about adjacent angles that says they have to be congruent. So nothing in this picture is telling me these have to be equal. I'm going to look over here. My first statement was 2 is congruent to 4. My next statement, 2 is congruent to 5. And then my conclusion, 5 is congruent to 4. Well, if 4 is congruent to 2 and 5 is congruent to 2, then these two have to be congruent to each other. Which property was that? Well, actually, it could be one of two properties. We could call this the transitive property. Now, this is not going to be a property of equality. Because these are congruent symbols, we wouldn't say POE, we would say POC for property of congruence. However, this could also be the substitution property of congruence, because essentially what we're doing is we're substituting this angle 4 in for this 2 because the 2 and the 4 are congruent. In general, anytime you could use transitive property, you can also use substitution. The reverse is not true. Transitive cannot always be used where substitution is. All right, step 4. Angle 1 is congruent to angle 4. In this diagram, angle 1 and angle 4 are vertical. This is VAT. Finally, angle 1 is congruent to angle 5. In this picture, angle 1 and angle 5 have no relationship. They're not vertical, they're not adjacent. Nothing in this picture is telling me that 1 is congruent to 5. So in my proof, this is going to be one of those cases where I probably need to look above to figure out why they would be congruent. Here we have 5 goes to 4 and 1 goes to 4. Well, if 5 and 1 are both equal to the same angle 4, it means they've got to be equal to each other as well. Just like in step 3, this is either going to be transitive or substitution, your choice.